Hello everyone, in this video series we are gonna build another data engineering project using AWS and Snowflake. This is our project architecture. We are gonna make use of AWS Lambda that will be triggered every 1 hour and which will fetch data from Weather API and dump it into DynamoDB. Then we'll be making use of DynamoDB stream which will pass its stream to AWS Lambda. AWS Lambda will process the data and load it into AWS S3. Once our data is loaded into AWS S3, our Snowflake will take a data from AWS S3 and load it into Snowflake database. This is the overall project architecture. DynamoDB is good at handling big amount of data, and Snowflake is great for analyzing data. When we combine them, it becomes easier to analyze data and make good decisions. Here, DynamoDB is our transactional database and Snowflake is our analytical database. Let's now go through each of them in brief. Amazon DynamoDB is a special kind of database that makes it easy to save and get data. It does not require fixed structure for data, so it can handle both organized and somewhat organized data. DynamoDB is fast and you can use it even when you need to access data quickly and often. This makes it great for dealing with different kinds of data. DynamoDB has special features called stream. These features give you a list of changes that your data have gone through. It is like timeline of what happened when. You can use streams to keep track of changes and do things automatically when data gets updated. This is useful for creating systems that respond to events, keeping data in sync, and doing real-time analysis on data. Snowflake is a strong data warehouse that lives in the cloud. It lets you save, get, and find data in a smooth way. With Snowflake, you can use regular SQL and more advanced SQL to handle different type of structured and somewhat structured data. This makes it easy to dig deep into the data, get better insights, and make decisions based on data. Snowflake makes use of something called internal and external stages to manage data. Internal stages help bring in data from local system, while external stage lets you access data present in cloud like S3 and puts it straight into Snowflake tables. These stages make it simpler to move data from AWS to Snowflake, making it a handy tool for data management. There are various ways to load data from DynamoDB to Snowflake. First, moving data manually from DynamoDB to Snowflake. In this method, we make use of DynamoDB export. We first export data from DynamoDB to S3, then we can download it into a local system or directly upload to Snowflake using the S3 or local system. Next, using DynamoDB stream. We are gonna make use of DynamoDB stream to ingest data from AWS S3 to Snowflake. DynamoDB stream will write a data to S3 using AWS Lambda. Then, using S3 as an external table, we'll load a data to Snowflake stages, then to Snowflake tables. Third method is to load using powerful tools like Airbyte and Talent, etc. Now, let's go ahead and start implementing our project. There are few requirements to complete this project. You need to have AWS and Snowflake account. You also need to have Weather API key token. You can generate the key token for free. Key token will help you to do an API call into a website and fetch a real-time weather data for different cities. You can make use of free tier AWS account, and also you can make use of 30 days free trial of Snowflake. To create a AWS account, go to aws.amazon.com and sign in. Fill your details and your card details, and you will be ready with your AWS account. To create a Snowflake account, go to snowflake.com and click on Start for free. You will be asked to fill in your basic details. Then choose AWS as a cloud service. Then you will be ready with your Snowflake account. You will receive an activation mail and a link which will lead you to the Snowflake account. To get the API token for the Weather API app, go to weatherapi.com and sign up. You will be able to see a free API token for your website. This is a dashboard you will be landed when you have successfully created your AWS account. Let's now go ahead and start creating our project. So, we first need to create a Lambda function and a DynamoDB table. Lambda function will make use of the API token and fetch a data from Weather API. Now, once the data is fetched, it will put a data inside a DynamoDB table. So now let's go ahead and first create a DynamoDB table. Let's go to DynamoDB. To create a table, click on Create Table. We need to provide an appropriate table name. Let's say I provide weather. So now I need to provide a partition and short key. Partition key is like a primary key. Partition key and short key together makes a primary key. Partition key is a hash value that is used to retrieve items from the table and allocate data across the host for scalability and availability. For this table, let's provide city as a partition key. Now, we have decided to fetch a data every hourly. So, in one day, there will be 24 same city. Hence, we need to make use of some short key to make a combination of city and time as a primary key. So I can write timestamp, or I can just write time. Let's leave all the other things as default. Click on Create Table. Now our DynamoDB table is successfully created. Next, we need to go ahead and create a Lambda function. Let's go ahead and review our code for a Lambda function, then we'll go and create a Lambda function. I have already returned the key. This is our code for Lambda function. We have first imported all the necessary libraries. Then we have created a DynamoDB resource that will help us to store a data or to push a data to a DynamoDB table. Next, we have defined a getWeatherData function wherein we'll provide a city and it will return a weather data at that particular timestamp. Next, we have a Lambda function, that is Lambda handler. We'll be fetching a data for the 10 cities like Bangalore, Delhi, Mumbai, Chennai, and so on. We can fetch the data for any city, but for this project I am keeping the number to 10. Then we'll loop through each city and we'll call the function getWeatherData for each city. Once we have called the function, we'll get the weather data inside a data variable. Then we'll fetch a data at the current timestamp, that is data, current, and temperature in Celsius. Then wind speed, wind direction, pressure, and humidity. It is just a log that will help us to see which all city is printed. We can make use of CloudWatch logs to monitor this. Then we'll take a current timestamp. Then we'll create a JSON out of it. That is city time. City is our partition key. Time is our short key. Then all the other data required. Then we are creating a JSON object out of it and we are dumping it into a table. So table is a weather table that we have already created. So now let's go ahead and create a Lambda function. To create a Lambda function, Let's duplicate it. Let's click on Lambda. So to create a function, click on create function. Now I need to provide an appropriate function name. Let's give it fetch weather data. Our runtime will be Python 3.10. We can make use of any, but for this project I am using Python 3.10. The architecture can be x86-64. Let's leave everything as default and click on create function. Now our function is successfully created. We have got a default code as of now, that is a Lambda function is created named Lambda handler that will return status code as 200 and body is hello from Lambda. If I just click on test, we can invoke a Lambda function. I am getting a response saying status code as 200 and hello from Lambda. I can copy the code that we have already written and paste it here. Now I can deploy a Lambda function. Now my Lambda is successfully deployed. I can test it. So I am getting an error saying unable to import a module Lambda function, no module named request. So we are getting an error, there is no module called request. This is because this dependency is not by default installed in Lambda. So to do that, we can add a layer. Click on layer and click on add layer. So layer is basically used to add dependency to our Lambda function. So we can add a layer. There is many ways to add a layer. One is AWS layer. There is few custom layers as well. So in a custom layer, we can create a layer from in our local system and upload in a form of zip file. But for this project, we are making use of already available layer, that is AWS SDK Pandas Python 3.10. I can add this. I can make use of any version that is available. Click on add. This will add the dependency that is required to run a Lambda function. Now click on test. Now I am getting another error message saying there is a key error called current. So I have not provided a key here, so I will provide a API key and get back. You can also provide your own API key here. I have provided my API key and deployed the Lambda function. Now let's go ahead and test it. Now I am getting an error saying access denied. This is happening because we have not provided access to our Lambda function to write into a DynamoDB table. So we need to attach a permission to our Lambda function that will enable our Lambda function to write it into a DynamoDB table. So to give a permission, click on configuration, click on role name. Now I can add a permission to this role, that is click on attach policies. Now to write into a DynamoDB table, our Lambda function need a DynamoDB access, that is I can provide DynamoDB full access. It is not a good practice to provide a full access. You can provide a write access on very specific access that is required to complete the project. But since this is just a project and I am doing for a demonstration purpose, so we can make use of DynamoDB full access. Click on add permission. Now we have successfully attached a permission. We can close this window. Now let's go to code. Now Let's go ahead and test it. Now I am getting an error saying timed out. So now our lambda function has been executed for 3 seconds and it is timed out. But we can see that almost like all the output is printed. That means our data must have been inserted into DynamoDB table. So now let's go ahead. Let's go to table. Now we can explore table items. We can see that the 8 items are inserted. Last 2 items have not been inserted because that is timed out. So we can, by default, the time for lambda function is 3 seconds. We can increase the time limit. To do that, click on configuration. Now click on general configuration. We can see that timeout time is set to 3 seconds. We can edit it and make it more than 3 seconds. Let's make it 15 seconds. Now save it. Now let's go ahead and delete all the record that is present inside DynamoDB table. Now let's go to weather data. Now let's go ahead and trigger our lambda function. Now we are getting a success response and all our records is successfully inserted into a DynamoDB table. We can go ahead and check it. We can refresh the page. Now we can see that 10 records, that is for different cities, successfully inserted. Now we have successfully completed this part. Now we need to create a DynamoDB stream and a lambda function that will take a data from a stream from DynamoDB and put it into AWS S3. Now let's go and create S3 bucket first. Search for S3. Click on create bucket. Provide an appropriate bucket name. That is let's provide everything as default. Go ahead and click on create bucket. Now our bucket is successfully created. Now let's go ahead and create a lambda function that will be able to process the DynamoDB stream and store it in this bucket. I have already written the code to create a DynamoDB stream. So I have first imported a necessary libraries like datetime, pandas and so on. Now there is a lambda handler. So what will happen is whenever there is some write that happens in DynamoDB table, it will trigger a lambda function. So now once a lambda function is triggered, see most of the event that happens in our lambda function is an insert event. So we'll check if the event is insert. If that is insert event, we'll call a function named handle insert. So what it will do? Now whenever DynamoDB passes a DynamoDB stream, it adds two values. One is new image and an old image. Since it's insert, so it will only pass a new image. So it will take a new image and it will create a data frame out of it and it will return that data frame. Once that data frame is returned, if it is not empty, we'll create a list, we'll add a column and we'll convert it into a str type, that is string type. Then we'll create a CSV file out of it and we'll write that CSV file into our S3 bucket. So we can add this bucket name here. So we can copy this and put it here. So inside this bucket name, we are using Snowflake as a subfolder. I can create a folder named Snowflake. Now I can click on create folder. Now that is done. After this, we'll print successfully processed this many records. Now let's copy this code. Let's go to Lambda and let's go to functions and create one more function. Let's name it as ddb stream ddb to Snowflake. The runtime we're using is Python 3.10 and click on create function. Now we can paste our code. We can deploy the code. So now, since pandas does not come pre-installed, we need to add a layer. Add a layer. Now we can, same like before, we can make use of pandas SDK. Click on add. So this Lambda function requires to write into S3. So it requires a permission to write in S3. So we can go to configuration. We can go to permissions. We can go to this one. Now click on attach policies. Let's give S3 full access. Click on add permission. Now our permission is added successfully. We can also increase our timeout time. Let's also make it to 15 seconds. And we are making use of lots of libraries and the data processing is also high, so we can increase the memory size to 250 as well. Yeah. Click on save. Now our Lambda function is successfully created. Now we need to go ahead and enable a DynamoDB stream that will trigger this function. Click on add trigger. Now the source for our trigger is DynamoDB. Now we can activate a trigger. Our table name is weather. Now the batch size we can, since we are processing only 10 records in a time, so let's make it 5. Now let's make it latest and we can click on add. Getting the error saying an error occurred when creating a trigger. So this is happening because we have not given our Lambda function required permission, that is get records, get shard iterator and so on. Let's go to our Lambda function. Let's go to configuration. Let's go to permission. Let's attach one more permission, that is DynamoDB full access. Now click on add permission. Now let's go to our trigger and click on add trigger. Now we can see that our trigger is successfully set up. Now to check whether our trigger is successfully set up or not, we can go ahead and click on fetch user data and let's test it. Once this is tested, it will insert a data to our DynamoDB table, and that DynamoDB table will automatically create a stream and will trigger our DDB stream to Snowflake Lambda function. Now we can go to our S3 and go to our project, go to Snowflake. It will take some time to load our data here. Let's wait for some time. Now we can see that our data is successfully loaded to our S3 bucket. We can download our data to see the CSV file. We can see that in this CSV file we have got a data for Bangalore. Just wait a second. Yeah, we have got a data for Bangalore. Yeah. Now, similarly, we have got in other CSV files, we have got the data for different states. Now we have completed this part till here. We have created a Lambda function, then we have created a DynamoDB table, then we have set up a DynamoDB stream, then we have created a Lambda function that will process the data using a DynamoDB stream and load it into S3. Now it's a time to create a Snowflake account and load this data to a Snowflake. Now let's go ahead and set up our Snowflake. I have already written the code for Snowflake. We'll go through the Snowflake code one by one. For this project, let's create a database name DE project. Let's make use of the database. Now we can see the schema of our database, that is city, time, humidity, pressure and all. Right, if you go, the city is string, time is string, humidity, pressure, temperature and wind speed is number, and wind direction is again string. So we have created a table same way. We have created a table named weather data, wherein we have a columns named city, time, humidity, pressure MB, temperature, wind direction and wind speed. Let's go ahead and create a table. Now our table is successfully created. Now we need to create an integration object. So integration object is used to connect your S3 with a Snowflake. So we need to create a IAM role that help us to connect our AWS account to Snowflake. Let's go to AWS. Let's go to IAM. Let's go to roles. Let's go ahead and create a role. Now we are creating a role for this AWS account. We can go to next. So we need to provide a S3. Let's go ahead and create a S3 full access. Now let's provide a name for the role, that is AWS to Snowflake. Now our role is successfully created. Now I can go inside this role. Now I can copy this ARN and paste it into this. Now I need to also provide our S3 location. So let's go to our S3 bucket and let's copy this S3 URI and paste it here. So now what this basically does is it will create an integration object and it will be an external stage. It will say the storage location is S3. So it is basically used to connect your Snowflake to our S3. Now let's go ahead and create our integration object is successfully created. Now we can describe this integration object. So now we have two very important things, that is our external ID and storage AWS location. Now since I have already done it from Snowflake side. Now we need to tell AWS that this Snowflake account will request access, and whenever it requests access, you must grant the access. So let's copy this role ARN. Let's go here. Let's go to trust relationship. Let's go to edit trust relationship. Right? Now instead of this, let's paste the ARN that we have copied. And in the condition, let's go ahead and click on add condition. Let's select external ID since our Snowflake is externals. So let's copy this external ID and it can be default. Operator can be string equals, paste the value here. Now this will help our AWS to authenticate the Snowflake. Now our integration object is well set up. Now we are having a data in a CSV format, so let's create a file format named CSV format. Let's run it. Now our file format is successfully created. Our header is, we are skipping the header. Now we have to tell the stage, like we need to define a stage. So to do that, let's copy our S3 location, that is a location of our external stage. Let's paste it in the, now when we have defined a stage, we are giving a link to our integration object and our file format. Now this way our stage is successfully created. Now we are creating a Snowpipe. What Snowpipe basically does is, like, our data will be coming from DynamoDB to S3 in a regular basis. So whenever new data comes into S3, it will tell Snowflake कि new data have arrived and you need to refetch it or ingest it again. So for that, we are creating a Snowpipe. So it will have something called auto ingest feature. So it will automatically ingest the data. So it is giving an error saying, assuming AWS role, please verify external ID are configured correctly in AWS policy. Setup, we have got that error because of this reason. When you go to describe integration object, so we have made use of this sixth one, we must use a fifth one, that is storage AWS IAM user ARN. We have to copy that, paste it in principal tag instead of the sixth one. So here, instead of the old that we have pasted, we have to paste the storage AWS IAM user ARN. So once that is done, we'll be successfully able to run this and our pipe will be ready. Now if I do select star from weather data, our data is not coming. So what we need to do is, we need to show pipes. Now what this basically do? Now we have something called notification channel. So we can see that there is something called SQS. Now what it basically does, whenever new data land into our AWS S3, it will basically trigger a notification to Snowflake that new data have arrived. Run the pipe object, that is run your ingest function and get data from S3 to Snowflake. So we can copy this, we can go to our S3, we can go to our properties, let's go down. Now we have to create an event notification. Let's give it some name. Let's create for any object, that is any object that enters into S3 will trigger this notification to our Snowflake. Now let's provide lambda function ARN. Sorry, SNSI topic, and let's provide the ARN for this. That is SNS only, right? Or it is SQS. So let's choose SQSQ and let's provide the ARN for the SQS. Now click on Save Changes. So now let's go ahead and trigger our DynamoDB once again. So let's trigger our Lambda function once again. So what that basically does is it will add a new data into our DynamoDB that will in turn run our DDB to Snowflake, DDB to S3 Lambda function, and that will call our Snowflake auto ingest, and that will take a data from S3 to our Snowflake. So now let's go to our Lambda function. Let's click on test. Let's invoke. Now this app successfully invoked. Now we can see that new records has been entered into our weather table. New records has been entered into our weather table. Now this will call our DDB to Snowflake function that will process the data and put it in S3. Then that will in turn call our Snowflake object. Now let's wait for some time for this process to get over. Now we can see that our data is successfully loaded to our Snowflake. Now whenever we insert any data into our DynamoDB, our data will be passed to Snowflake automatically. So we have created a whole part, that is we have created a Lambda function that will trigger a weather API and put a data inside a DynamoDB. Then we have set up a DynamoDB stream and a Lambda function that will process that stream and load a data to S3. Then we have created a Snowflake account and loaded a data from Snowflake from S3 to Snowflake using Snowpipe. Now only thing that is remaining is to schedule our Lambda function every 1 hour. Let's go ahead and do that. Let's go to the function. We need to call this function every 1 hour. To do that, we have a service named EventBridge. Let's click on Add Trigger. Let's make a source as EventBridge. Now we can create a new rule. Let's create a rule named trigger every hour. So we can put our own pattern. We can put a pattern like rate 1 day, or we can add our own cron job. So for our case, we need to trigger in every 1 hour. So let's write rate 1 hour. So it will trigger our cron job every 1 hour. Click on add. So it will trigger the function every 1 hour. So this way we can see that our cron job is enabled. This way we have completed our project. So let's walk through the every points once again. We had created a weather API wherein we have got an API key that helped us to write a Python script that will fetch a data from weather API. Next, we have created an EventBridge schedule that will trigger our Lambda function every 1 hour. Now what this Lambda function will do? This Lambda function will take data from weather API and store it into a DynamoDB table. Once data is inserted into the DynamoDB table, it will automatically generate a DynamoDB stream. Now this stream will be processed using Lambda function and it will be loaded to our AWS S3. Now once data is loaded to AWS S3, we had something called Snowpipe that will send a notification using a SQS queue to our Snowflake. Now once our Snowflake is notified, it will ingest the data from S3 to Snowflake, external stage. So we have completed this project. Hope you have enjoyed working on a project with me. For more such project, do like and subscribe. Thank you.